Hey everyone, welcome to Code Upwards, the place where we break down algorithms, data structures and LeetCode problems in the most intuitive and engaging way possible. If you're preparing for a technical interview or just want to sharpen your problem solving skills, you're in the right place. Today, we're tackling one of the most famous coding interview problems of all time, two-sum. The question is a fan favorite among fan recruiters, and if you've ever opened LeetCode, you have definitely seen it before. But trust me, even though it's considered an easy problem, there's a lot to unpack here. By the end, you'll not only understand how to solve two-sum efficiently, but also be able to apply these problem-solving techniques to harder challenges. So, grab a coffee, hit that subscribe button, and let's dive in. Alright, let's start by understanding what the problem is actually asking us to do. So, given an array of integers, called nums, and an integer called target, return the indices of the two numbers such that they add up to target. And then we have some disclaimer and conditions here. So we may assume that each example will have exactly one solution. We may not use the same element twice, and the order of the indices in our result doesn't matter. So if we look at our first example here, we can see that nums is equal to 2, 7, 11, 15, and our target number is 9. So what we are asked to do is to find the indices of two numbers in this array that add up to 9. One first brute force approach would be to test all different combinations of numbers in this array, and if they sum up to 9, we can return them. So we would start with a 2 and a 7, and sum these up, and they actually correspond to 9 in this example, but let's say they don't, to continue with the example. Then we'd go to the next combination, so 2 plus 11, and then to the next combination, 2 plus 15, still not 9, and then go to the next combination, 7 plus 11, and so on, until we found the combination that actually sums up to 9. While this is definitely a valid solution, this will not give us the most efficient runtime, because let's say we have n elements in this array. By doing all possible combinations between these numbers, we will end up with a runtime of n squared. And I think we can do better. And we will do better using a data structure in Python called dictionary. For Java developers, this would be a hash map, which is a key value store that maps values, so keys to other values. And let's take a step back and think about this problem. So when we look at the first number, we look at the 2. What do we want? We want a number that, if we add it to 2, leads to our target number 9. So we can compute this number. We can say, okay, we are looking for 9 minus 2, which is equal to 7. Now, if we would know where in the array the 7 is, then we could return our current indice and the indice of 7, and would have our solution. And one way to do this is by having a dictionary that maps values we have already seen to their position in the array, so the index. So let's create a dictionary using curly brackets here. And when we start with the 2, we compute what's remaining, so 9 minus 2, this is a 7. We look at our dictionary with the values we have already seen before. If we have ever seen a 7, no we don't, because the 2 is our first number. So what do? We write our current number into the dictionary with its indice. So we say, yeah, okay. Then let's say, yeah, if we are ever looking for a 2, you will find it at index 0. And then we are done with the 2. And we'll go to the next number. Now we're at the 7. Now we compute what's remaining, so we compute 9 minus 7, which is equal to 2. And then we look at our values that we have already seen. We're looking for a 2, and we see, there's a 2. And we know where to find it. We know it's at index 0, and we have our current index, which is 1, so we can return 0 and 1. And those two numbers at these indices will sum up to 9. Let's say this was not a 7, but it was a 6. Let's say this was not a 7, but it was a 6. Then we would have a remaining of 3. We would look here, see, no 3, so we would write our 6 into the dictionary and the position 1, and go on. So that's how we would build this dictionary. And like this, we will go through the array once, and because we are guaranteed that there will be a solution, we will have found a solution at the end, because at some point, at latest if we are at the last index, we will find the corresponding remaining number in the values we have already seen, and we can return it. And so we will only have to traverse the array once, which will end up in a runtime of O of n. I hope that made sense. So let's dive into the code. Okay, so we are here in LeetCode. I hope the environment is familiar to you. So first of all, what we want to do is we want to initialize our dictionary. So let's call it nummap and initialize with an empty dictionary. And this is the dictionary that maps numbers we have already seen to their position in the array. Then we will iterate through our nums array. So we'll say for, and we not only want to have the value, but also the current index. And in Python we can do that using the enumerate method. So we can say for I num in enumerate nums. And in every iteration, the I will give us the index and num will just give the actual value in the nums array. We want to compute what's missing. So what is the remaining value that we need to hit the target? So we'll say remaining equals target minus num. And then we want to check if that remaining value is part of nummap, if we have already seen that value. So say if remaining in nummap, then we know, okay, we have a solution, so we can return. What is our solution? Our solution is the indice we're currently at, so that's I, and the indice of the remaining value. So that would be nummap of remaining, because that's how we constructed nummap. We are mapping values to the indice. Now, if remaining was not yet part of the dictionary, what we want to do, we want to save our current value into the dictionary so we can find it later in the future. So we'll say nummap of num equals to its current position, so I. And I know we will always have a solution, but let's just return an empty array in case we would not find one. So, and that's basically it. That's the solution for TwoSum. Let's run the tests. Looks good so far. And if we want to submit it, that should also give us a positive response. And you can see, very efficient solution. So that's a wrap on the TwoSum problem. We have covered the brute force approach, which is slow, takes n squared runtime, and then a faster approach that runs in linear runtime. And I hope you found this breakdown useful. So smash that like button, subscribe, and hit the bell so you don't miss future videos. Thank you for watching, and I'll see you in the next one. Keep coding upwards.